All right, chapter 9, section 5, sine and cosine ratios. Last class we did tangent. If you understood how to use the tangent, the sine and cosine are very similar. They're just using different ratios. So if we know the ratios using SOHCAHTOA, this should be pretty easy. So for SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So today we're focusing on sine and cosine. All right, our sine and cosine. Let triangle ABC be a right triangle with acute angle A. The sine of angle A and cosine of angle A are defined as followed. Okay, so it's just kind of telling you the setup according to a specific angle. So again, if we know our SOHCAHTOA, we know what goes where. So with sine, we have opposite over hypotenuse, and cosine is adjacent over hypotenuse, but depends on which angle they're asking for. So for the first set of notes, or the first one, they're asking for angle A. So here's angle A. According to angle A, C is my hypotenuse. It's opposite that right angle. B is my adjacent side, and A is my opposite side. So if I'm looking at sine A, sine is opposite over hypotenuse. Okay, which that's what they're giving us. And then cosine is adjacent over hypotenuse. So again, when we're looking at these, opposite over hypotenuse, adjacent over hypotenuse for cosine. Looking at the next one, if I'm looking at angle B, now this becomes my opposite side. This becomes my adjacent side, and my hypotenuse stays my hypotenuse. So looking at this one, for sine, I have opposite over hypotenuse. And cosine, I have adjacent over hypotenuse. Again, this is all according to the angle they're giving us. All right, SOHCAHTOA, they're writing it out for us. They want us to fill out the ratios. So yes, I am also going to write it. Again, if you're spelling these incorrectly, it's going to mess you up on your ratios. So sine, I'm going to have opposite over my hypotenuse. Cosine, I'm going to have adjacent over my hypotenuse. And then tangent, I'm going to have opposite over adjacent. All right, looking at example number 1, it says express sine A, cosine A, tan A. So that's what I'm going to do first. And then they want me to find sine B, cosine B, and tan B as a fraction. So I'm just really writing them as their ratios, just so I have it. Make sure I'm following the correct setup. I'm going to label what I have. And the first thing I'm going to do is I'm going to look at angle A. That's what they want me to solve for first. So according to this angle, 5 is my hypotenuse, 4 is my adjacent side, 3 is my opposite side. So labeling what I have first, I have sine A. Looking at sine, what over what? I have opposite over hypotenuse. What's my opposite side? What's the measure of my opposite side according to angle A? 3. What's my hypotenuse? 5. Good. Okay, now looking at my cosine A. Cosine is adjacent over hypotenuse, so what's my adjacent side according to angle A? What's my adjacent side according to angle A? Anybody, what's the measure? Yeah. 4 over 5. Good. And then the last one is tan A. So we did tangent last class. What's the opposite side, Kaden? According to angle A, what's my opposite side? What's my opposite side? And what's my adjacent side? Okay, so I have 3/4. Looking at the next side, I'm looking at my angle B. I need sine, I need cosine, and tangent. However, according to angle B, this is now my opposite side. And this is my adjacent side, and this stays my hypotenuse. So I have sine B. Sine B. Sine is opposite over hypotenuse. So what's my opposite side to angle B? 4 over what? 4/5. And then looking at cosine B. Cosine is adjacent over hypotenuse. Nathan, what's my adjacent side to angle B?
3.
What is it?
3.
What's my adjacent side to angle B?
3.
3 over what? What's my hypotenuse?
5.
Good. And then my last one is my tangent B. This is opposite over adjacent. So what's my opposite side? Michaela? What is? Say it one more time. 4 over what? Good. Okay. Looking at this, something that we need to understand. When I have complementary angles, sine A is going to be the same measure or ratio as cosine B. And cosine A is equal to sine B. Okay, that's something that you guys are going to have to remember. Sine A is equal to cosine B, and cosine A is equal to sine B. Okay, so that's kind of to the next slide. Sine and cosine of complementary angles. The sine of an acute angle is equal to the cosine of its complement. And the cosine of an acute angle is equal to the sine of its complement. So this is kind of what I just said. Sine A is the same as cosine B, which is right here again. And cosine A is the same as sine B. So please make sure you guys remember that. It says use a calculator to find. However, the first one, sure, you could plug that into a calculator and you're going to get 0.5. But you need to know how to solve using special right triangles because sometimes they're not always going to be a decimal. And if you're giving it to me as a decimal, it's going to be wrong. So I'm going to draw this one out so you could see it. Okay, I have my special right triangle. I have my 30. I have my 60 and I have my 90. Looking at it, labeling the sides, I have 1, I have 2, I have the square root of 3, and they're asking for sine 30. So just so I have it, I'm going to write my SOHCAHTOA. And I'm looking at angle 30. Okay, sine is opposite over hypotenuse. This is my opposite side. This is my hypotenuse. I'm going to have sine 30 equals 1 over 2. So yes, if you plugged it into the calculator, you got 1 over 2 or 0.5. That is correct. But keep in mind, when it's a special right triangle, sometimes it will have the radical. When it is a special right triangle, if it is in radical form, you have to give it to me in radical form. You cannot give me the decimal. So B is not a special right triangle, so plug that one into your calculator. Go ahead and round to the nearest hundredths place, and what would you get as your answer? Yes?
0.74.
Good, my answer should have been 0.74. Now, looking at B and D, or yeah, C and D, what do I have to do in order to solve for my angle? Yeah. I have to solve using the inverse. Okay, which is that little -1 at the top. So solving it round to the nearest whole, who could tell me sine what equals 0.1045? Gabriel, did you get that one? What is it?
Oh, let's
Good. My answer for this one is going to be 6 degrees. And the last one, what is the angle for this? Can someone give me that angle rounded to the nearest whole? Good. Thank you. It is 15 degrees. Any questions on this? Okay. All right, looking at example number 3, it says find the values of x and y to the nearest integer. So, still writing my SOHCAHTOA. All right, and looking what I have, they're giving me my angle. So according to this angle, I have my opposite side, my adjacent side, and my hypotenuse. So I'm going to go ahead and solve for x first. Okay, using process of elimination, solving for x. Which one am I going to use? Am I going to use sine, cosine, or tangent? Looking at it, thinking about it, which one am I going to use? Sine, cosine, or tangent? So this is when all of them come into play. How are we going to use them? Which one am I going to use? Yes. Okay, so I'm solving for x. For tangent, I need my opposite side and my adjacent side. Does that give me enough information to solve for x? No, so then I can't use tangent. Can I use cosine? I can't use cosine either because I'm solving for x, and x is my opposite side. So I know I'm going to have to use sine. So you guys have to be able to use that process of elimination. Which one am I solving for? So solving for x, I'm going to use sine. I'm going to have sine 28 equals opposite over hypotenuse. So solving, I'm going to go ahead and multiply both sides by 1,000. All right, multiply both sides by 1,000. These are going to cancel out. If you plugged it into your calculator and solved it correctly, x equals round to the nearest whole number, nearest integer, what did you get? Good, 469. Okay, there are 2 ways that I can solve this. One way is I can solve using tangent, or I can solve using cosine, and I'm still going to get the same answer. How can I solve using tangent? Okay, so I'm going to write both ways. I can use, I'm going to write it underneath. I can have tan 28 equals, tangent is opposite over adjacent, so I'm solving for y. Or I can use cosine, which is my adjacent side over 1,000. So does it matter which one I use for my homework or whatever? No. So come day of your test, if someone decides to use cosine, someone decides to use tangent, we're still going to get the same answer. It's more personal preference or whichever kind of rule you see first. Personally, I would use cosine just because I'm only multiplying both sides by 1,000. So if I was solving using cosine, all I have to do is multiply both sides by 1,000. These are going to cancel out. If I multiplied correctly, y is going to equal what? To the nearest whole number. Yeah. 883. Okay, so for this one, you could solve it multiple ways, but just please make sure you're following the rules. All right, looking at example 4, it says find x, correct to the nearest degree. So I'm just going to write my SOHCAHTOA. And according to angle x, I have my hypotenuse and I have my opposite side. Which one am I using? Do I have any adjacent information here? No, so I'm not going to use cosine. I'm not going to use tangent. I'm going to go ahead and use sine. So I have sine x equals 18 over 30. How do I solve for my angle? What do I have to use? What do I have to use in order to solve for my angle? I have to go ahead and use the inverse. So I'm going to use the inverse of sine. And then 18 over 30, that's what it should look like in your calculators. Go ahead and click enter. And rounding to the nearest degree, the nearest whole number, x is going to be how many degrees? What did we get for x? Yep. 37 degrees is my answer. Good job. All right, looking at example number 5, it says find the measure of the 3 angles, round to the nearest tenth. So who could tell me what kind of triangle is this? Good, it's an isosceles triangle, so I know I'm going to have 2 of the same angles. Angle B and angle C are going to be the same measure. And I don't have a right triangle here. So I'm going to make a right triangle. I'm going to bisect it in half, which then is going to split these 2 angles, or these 2 now new segments. I'm going to have 2 over here and 2 over here. So it doesn't matter which one I solve for first. I'm going to go ahead and solve for B. Remember, B and C are the same. So looking at this, I'm going to go ahead and again solve for B. I'm solving for angle B. So angle B, what do I have? I have my hypotenuse and my adjacent side. So let me go ahead and write my SOHCAHTOA. So which one am I going to use? Sine, cosine, or tangent? Which one? Am I using sine, cosine, or tangent to solve for angle B? Good, I'm going to use cosine. So right now I have cosine B equals 2 over 5. I'm solving for my angle, so I have to use my inverse. So it's going to look something like cosine -1 times 2 over 5. Go ahead and plug that into your calculator. And what would you get for the measure of angle B? Rounded to the nearest tenth. Good. The measure of angle B is 66.4. So that means angle C is also 66.4. So how would I find the measure of angle A? Yes. Good, I'm going to add them, then subtract from 180, and I'm going to get what's left over. So adding them or multiplying by 2, 66.4 plus 66.4. You're going to get 132.8, and then subtract. If you subtracted correctly, what did you get for angle A? What do we get for angle A? What was that? What do we get? Yeah. 47.2. Okay, so yes, I got my answers. We know how to solve for what's missing. All right, looking at these, sine and cosine and special right triangles, they gave me the setup for my special right triangles. I'm solving for sine and cosine of both angles. So looking at this, I'm again writing my SOHCAHTOA just so I have it and I remember it. All right, looking at this one, labeling according to angle 45. I have my opposite side, my adjacent side, and my hypotenuse. So looking at it, I'm going to go ahead and do sine first. I have sine 45 equals my opposite side over my hypotenuse. Keep in mind I cannot have a square root as my denominator, so I have to rationalize it. If you rationalize your denominator correctly, you should have the square root of 2 over 2 for sine. And then solving for cosine 45. Adjacent side to 45 is 1. My hypotenuse is still going to stay the same. So both my answers are going to be the same thing. The square root of 2 over 2 is my answer for both sine and cosine of 45. All right, and looking at the last one, I have sine and cosine of angle 30. So according to angle 30, this is my opposite side, this is my adjacent side, this is my hypotenuse. So I have sine 30. What's opposite of angle 30? 1, good. And what's my hypotenuse? 2 as a whole. Do I have to change this or simplify it in any way? No, I have my answer. And then let me go ahead and do cosine of 30. What's my adjacent side to 30? Square root of 3. And what's my hypotenuse? 2. Do I have to simplify or change that in any way? No. Okay, so these are my answers. Keep in mind they will not change unless they're giving me the measure of a side. In last class, we covered angle of elevation. This is now angle of depression. Elevation was, the angle of elevation was going up. This is now going down, okay? It's the downward line of sight that makes a horizontal line. So this is going down. So you will get a word problem on your test. Whether or not it's angle of depression or elevation, please make sure you read the word problem correctly. So looking at this diagram, it says you are skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance x you ski down the mountain to the nearest foot. So angle, your altitude. You have to know what your altitude is. Okay, if you've ever flown in a plane and they say we're at the altitude of 5,600 feet, that's the altitude from the plane to the ground. That's your 90-degree angle. That's your perpendicular line. So please be aware of where your altitude goes. If you're drawing this and labeling it, be aware. As well as your angle of depression, please do not draw your angle of depression down here at the bottom because then that's changing what you're plugging in. It should go here right at the top. So I know I have, or I'm trying to find something, so I have my SOHCAHTOA. And according to my angle, what do I have? They're giving me my hypotenuse and my opposite side. So which one uses your hypotenuse and opposite? Is it sine, cosine, or tangent? It's going to be sine. So I know I'm going to go ahead and I'm using sine. There are no adjacent sides. So I'm using sine. So for this one, plugging in what I have, I'm going to use sine 21 equals my opposite side over my hypotenuse, which is x. How am I solving for x? What do I have to do first? What am I going to do? I'm going to multiply by x. I'm then going to get x times sine 21 equals 1,200. Now I'm going to go ahead and divide both sides by sine 21. And then what do I have? I have x equals 1,200 over sine 21. If you plug that into the calculator, they asked for nearest foot. What would I get as my answer for x? Nearest foot. Yeah. Good. X equals 3,349 feet. All right, questions on this lesson? Again, if you understood tangent, this is just using sine and cosine.